actually reach
Hi, this is
another
Xochitl,
limit of the
and
potentiometer.
I'm Alejandra.
So what it's doing is it has
Alejandra,
just
and
a
we're going to show
certain
you about our Sentry
degree of the
Simulation.
circle that it can actually spin.
So, I don't know if you guys can
You
tell
wouldn't want to put this on a
we have our
drivetrain or any other motor
for our
that
standard
would be
model
able to
square
spin
bot in control rolls.
360 degrees around.
We have our
Because
while
the
loop here, which makes sure
limits
that
motor from doing
the program that we write is able
So
to.
where you see this most often is
I guess
on ARM. An ARM doesn't always need to spin
Right,
365
at the computer.
degrees.
Because as long as 1 is equal to 1, you will have a program that runs. Here we have our code on our 8th line. Left motor is equal to 127. That is our speed. We'll go off full speed. So I'm going to type our pseudocode robot
The actual shaft rotation.
runs
This is
at
this
full
the
speed.
encoders will reset every time you
127.
do another program. This potentiometer,
Or
however you rig it onto your robot,
left
is
motor.
going to be set. So your values aren't going to reset to 0. So if I told my robot
On our 9th line, we
move
have
its arm
motor,
to
right motor is
potentiometer
equal to 127.
350,
Because your right motor is also
it's
going
going
at
to
full
be
speed.
at that same
So you would
spot
go
wherever
right motor
every single time I use it, as long as it's rigged the same way.
runs at
So
full
with the potentiometer, you're going to have to do a lot of testing in order to get your get it where you
Now,
want.
on our next
Because
line
as
here,
you can see,
we
there's
have
no marking
wait in milliseconds,
where
3,500.
that one
Now, you may be
stops
asking,
and when the up or the other
milliseconds?
stops.
What's a millisecond?
So you really are
Well,
gonna have to
Alejandra,
go
why don't you
through
explain
and
to them
check
what a
out,
millisecond is?
which I'll show you exactly.
Well,
how to do.
Alejandra doesn't know what a millisecond is. A millisecond is
So a little bit more,
100.
these stops, the internal
A
mechanism
millisecond.
that stops
A
the
millisecond.
potentiometer
So we have
during
3,500ths of a second. That would be
But the
3.5
limitation with that
seconds.
is
So on our pseudocode, we're going to write
internal mechanism stops,
robot
which can be caused by hand
waits
or vex motor, will cause them to
3.5
wear away. So those little
3.5
stops are going to get
seconds.
weaker and weaker and weaker, and eventually break.
on our next
And
line,
that's
which is
completely
9,
normal. The
line
sensor will
11,
still work
we
fine,
have motor,
but
left
you're gonna
motor
get
is equal to
what's called
65.
the dead zone of where the mechanical stops
Whoops.
work.
Looks like I
So
deleted
if
my
you
one.
drew a circle, I might be able to draw this out. So if I draw a circle, and I have one stop zone right here,
There you go.
the
My
other
apologies.
stop zone right here,
So here we have motor,
let's
left
say
motor
this was
is equal to
0,
65. Alejandra, why don't you
and
explain
this
to
was
them
our
what exactly does that mean?
1095. And we rotate it this way, clockwise. So clockwise, our values are going to increment up to 4095,
Go ahead.
or about 4095. If we get
Why
to
don't
this
you
stop point
explain
and break through,
what the speed of 65
this is what's
means?
called a dead zone. The area between
Okay,
495 and
65 is
so that
half
dead zone, when we look at our sensors and debugger with it, it's going to read,
127.
it's going to
So
tell us that
I guess
it's
what she
at
means is
4095
65 is half speed.
until it
which
reaches
means
the
that
0. And if this nub is broken as well, it'll go past 0 and then start calculating again. So the sensor
Runs
doesn't lose
at
all of its
half
usability if those nubs break, but you will get a dead zone. If you were rotating it the other way,
Now, Alejandra,
if you were
what does that
rotating
okay,
counterclockwise and you broke the
Negative
0
means
nub off,
that it's going
the dead zone
backwards.
would report 0
Reverse.
up to 4.
okay, and why is that important in this challenge?
Because it makes the robot turn.
Whoa!
So that basically
Our robot
you have to,
turns. So
know
that means
if
that our
your
right motor
potentiometer is broken and you start seeing those results and your arm is turning,
will
but
run
you're just
in
reporting
reverse.
4095.
Or,
that maybe
oh,
you
reverse
just
half
stopped
speed,
to
my
reach and
apologies.
you're actually in the dead zone.
Negative
No,
65.
and then you put
Here's an
it makes
example
it turn.
using potentiometers.
Right.
I'm not going to get into
Or we
it.
could just
We're
leave it
going to
We'll just
go
leave it
over
at
a
that.
different program here in a little bit. But as you can see,
And
you just use it the same.
Here we have our last
way
line, Alejandra.
As
Okay, to end it.
at the touch sensor.
Why don't you
use
explain
that sensor value
what the
command,
wait in milliseconds
and you put in
1230
where
means?
that's the name of our photometer is less than 645. So this is a really cool program that I'm going to show you guys and walk through. It's basically going to replicate, we're going to use the rotation of the potentiometer.
She's
to control
obviously
how
too nervous
fast
to
the
speak,
robot's
so I
moving.
will.
So this is
A
going
wait
to
in
be a cool
milliseconds
physical
of
experiment.
1230
And what
means
we'll
that
do
you will
is
wait
we'll put the robot
12
on the
seconds.
walk so the wheels aren't actually touching the ground.
12.3
And what will
seconds
happen is
before
we're
running
gonna
the
have the
command.
arm
So we'll have
like think of a jet throttle. We're gonna push the arm
motor.
up, and our motors are gonna spin faster and faster before we go up.
robot. My apologies.
And then if we
Robot.
pull the arm back down, the wheels will then
Wait.
spin slower and slower. And we're gonna put those motors
Seconds.
on the same scale as the. We're gonna put the motors on the same scale as the potentiometer. Let's check out what this program is.
And that is it. So let's see if it works. Alright. Ready? Dun dun dun!
So I'm gonna open a new file. Robot Virtual Worlds offers the SquareBot.
we
The
have it.
SquareBot has a potentiometer on its arm. It might be a
That
little
reminds me of
hard to
that
see
song.
here, but it does have a potentiometer on its arm.
Script.
And before I go through this, I gotta
Goes,
know
"Pull
what
up,
the values
skirt,
are,
get in
what
the-
values
Oh,
that
whoa!
we expect
Success.
to see from
Challenge
the
complete.
potentiometer.
Oh,
Like I
you
said
think
before,
it's
Us.
got it?
it all depends on how the robot
This
is
is
rated.
Xochitl.
So you can use this
And
technique in physical,
Alejandra,
or
right?
you can use
Yeah.
this technique
Okay.
in virtual.
And
What I'm
since
gonna
he told
do
us
is
it's not
download
doing
an empty program.
So,
I just set my
how about
SquareBot, my motor
tell a
sensors,
joke?
which is very important.
what?
As long as you set up your
No,
sensors
just
correctly,
What do you call
you'll be
No.
able to
an
set
owl
it
that
up.
does magic tricks?
I'm gonna download this empty program. It should do nothing.
Houdini!
Call this arm.
That's it for today.